Welcome back, everyone, to the Unlock Project podcast. I'm Meryl, your host, and this podcast is brought to you by Greenovate Europe. We are here to talk about the EU-funded Unlock project, which aims to convert chicken feathers into bio-based plastics. In each episode, we explore different aspects of the project, focusing on the contributions of each project partner. Today, we are joined by Jonna Almqvist, a project manager at Processum, which is part of Rice Research Institutes of Sweden. Processum supports innovation in the biorefinery sector, helping industries transition towards more sustainable practices by developing technologies that convert biomass into valuable products. Processum plays a crucial role in the Unlock project by developing and optimizing the steam explosion technology. This technology is key for efficiently extracting keratin from feathers, which is then used to produce bio-based plastics. And today we'll discuss the steam explosion technology and how this technology is being scaled up for commercial use and its integration into a biorefinery setting. So join us for this podcast episode today. So welcome, Jonna. It's great to have you here. Could you start by introducing yourself and telling us more about Processum's specific role and responsibilities within the Unlock project?
Yeah, sure. Thank you for having me. I'm working as a project manager at Processum, and Processum is an innovation hub based in Sweden. We're working with advancing bioprocesses and biorefinery technologies. And we're also part of RISE, which stands for Research Institutes of Sweden. So mainly, Processum focuses on developing new ways to turn biomass like forest or agriculture waste into valuable products. And when it comes to the Unlock project, Processum is involved in different tasks. First, we work on developing and optimizing the bioprocesses included in the project, mainly the steam explosion. So this means that we take the raw material, in this case feathers, and we figure out how to efficiently convert these into useful products. And this involves a lot of testing and refining to get the processes just right. And we're also involved in the scaling up of the processes. So that involves what works in the lab might not work on a larger scale. So Processum tests the process in a pilot plant to make sure it's feasible for industrial use. And this step is crucial to ensure that the innovations can be implemented in the real world settings.
So Processum is really important in the project leading the development of the steam explosion technology. So could you give our listeners a more clear picture? Could you explain what steam explosion involves and why it's particularly chosen for feather treatment within the Unlock project?
Yes, sure. The steam explosion is a process that is used to break down biomass, like feathers, and making them easier to process further. And it's normally used for treated lignocellulosic biomass as wood chips. But in Unlock project, we apply it to feathers. And the process works like this. So we place the feathers in a chamber where they're exposed to high pressure steam. And it's about 20 bars, and the temperatures are ranging from 160 to 220 degrees Celsius. And after a set amount of time, maybe 4 to 10 minutes, the pressure is released very rapidly. And the sudden drop caused the steam inside the feathers to expand explosively, so it breaks apart their structure. And the feathers are mainly composed of keratin. It's a tough protein that's really hard to break down using traditional methods. So steam explosion is very effective here because it disrupts the keratin structure. Unlike some chemical treatments, steam explosion doesn't involve harsh chemicals. So it's a physical process, which is much better for the environment.
Thank you so much. That's very interesting. And how does steam explosion compare to other feather treatment techniques like microbial fermentation and mechanical grinding in terms of scalability and environmental impact?
Yeah, that's a good question. Each of these methods has its own strengths and weaknesses when it comes to scalability and environmental impact. Steam explosion is very good because it's effective and it's scalable, and it's used in industrial applications already for other purposes. But it does, however, require a considerable amount of energy to generate the high pressure steam. Fermentation, on the other hand, it's very good because it's environmental friendliness, but it's slower since it's using microbials to break down the fibers, and it's also more complex to scale. And mechanical grinding is simple and it's cost effective, but it's very energy intense. So choosing the right method depends on all of these factors and what you want to gain in the end.
And Processum is actively involved in scaling up the steam explosion process. And for this, you have started activities at the biorefinery demo plant. So can you describe the activities at the biorefinery demo plant and how it is adapted to handle the further processing?
To scale up the process, we collaborated with the SEKAB, which has the biorefinery demo plant, and it's located next to us here in Sweden. And this facility has been processing biomaterials continuously for research and educational purposes for years. And it can be run 24 hours per day, and it can handle up to 35 kilos of raw material per hour. We had to adjust the process to the feathers since it's normally treating wood or straw. The feathers are much more lightweight and less compact. So we did change the rate the screws feed the material through the reactor. And we also tried adding different amount of waters to alter the density of the feathers and to reduce the amount of particles that is released from the feathers when they are moving.
Okay, I mean, you just mentioned already a few of those difficulties because scaling up technology can always comes with a set of challenges. So can you share any difficulties or more in detail that you faced when adapting the steam explosion process to fit the biorefinery demo plant and how these were overcome or how you are aiming to overcome these?
Yeah, there were actually less challenges than we expected, but we had very experienced operators in the plant, so they could adjust the things as problems came up. So they adjusted the flow rate during the trial to make the process run smoothly, and there were no plugs and no unprocessed materials. However, the downstream treatment of the material after the steam explosion, it involves dewatering, and this was harder than in the previous small-scale experiments, mainly due to the higher water content, because when we adapted it to a continuous process, we needed to add more water to be able to pump it through the reactor. And therefore, there were much more water to handle afterwards. So this is something that we need to look more into, how to handle this.
Now I would like to ask you the last question. Can you explain how the work that is conducted by Processum within the Unlock project fits to the overall project and fits within the overall aim of Unlock?
Yeah, sure. So the purpose of having the feathers treated with steam explosion or the other methods mentioned also is to break down the fibers and make the keratin available. And in the Unlock project, we have sent the processed, dried and ground material to other partners for further testing and application. So it has been tested as an additive in bioplastics to improve the biodegradability because the properties match well with cultivation accessories, and as for example, mulch films, hydroponic foams, and seed trays.
Thank you, Jonna. Thank you so much for joining the podcast today and providing this very short but insightful information about Processum's work within the Unlock project.